Okay, IBAISL2. Sorry, I'm starting off a little scraggly on that one. We're back with more chi-squared. It's still all of 8.2 is chi-squared, and it definitely needs to be broke up into 2 lessons. First up, we've already learned this in the last video, but if the chi-squared is less than the critical value, you accept. Remember the critical value from that table I provided you guys with. You accept the HO. That is to say the null hypothesis. If the chi-squared calc is bigger than the critical value, you reject the HO and say that you accept H1, which is the alternative hypothesis. With chi-squared, that would mean that if you're accepting the HO, that this is independent, the 2 parameters are independent of each other. And if you're rejecting, this would mean that the 2 are dependent. Remember, chi-squared is an independence test. There is another way to do this, and both are acceptable in this unit at this point. Sometimes it's kind of a pain to find that table and look up the critical value and stuff like that. So if you're finding chi-squared on your calculator, it also tells you a p-value. So you can compare the p-value with your significance level. If the p-value is greater than the significance level, for this example, I'm just picking 5%, but it could be 10% or 1%. It usually says in the problem what they want you to test it at. But let's say they said tested at 5%. If the p-value is bigger than 0.05, you would accept the HO. If the p-value was less than 0.05, you reject the HO. Mrs. Railsback, who used to work here, was like the stats queen, and she taught me this phrase that you can always remember for hypothesis testing with a p-value, which is if the p is low, reject the HO. Which is true. If your p-value is under, if it's small, if the p is low, you reject HO, which is the null hypothesis, and you accept the alternative hypothesis. Either methods are acceptable, but know how to work with both. So this means really, to be real with you guys, like the p-value is probably the easiest way to go with homework problems and such, but know that on a test we might be like, hey, let's say hypothetically you found chi-squared and it was 12.5, and the table was this big, and here's the critical value table. Tell us whether or not you're going to accept or reject the null hypothesis and why. So you need to know how both of them work. I always think of this as kind of opposite relationships, because here, if chi-squared is less than the critical, you accept. But here, if the p-value is bigger than the significance level. There it is. If the p-value is bigger than the significance level, you accept the HO. So it's like here, chi-squared has to be small to accept, and here the p-value has to be big to accept the null hypothesis. So it's kind of like an opposite relationship. First example today, 80 people were asked their favorite genre of music: pop, classical, folk, or jazz. Where would I fall? I guess given those options, either pop or jazz or folk, not classical. Well, no, I have a dog in each fight. But enough about me, guys. They asked 80 people, and these were their responses. They have also included totals for us, which is great because we're going to need those totals for the expected frequencies, there's always a question about expected frequencies. Null and alternative hypothesis. The null would be gender and favorite music genre are independent of each other. The alternative, gender and favorite music choice are dependent. Meaning if you're identify as male or female, that's more likely that you'll choose a certain genre. Show that the expected value for a female liking pop is 21. Well, that word expected means that you have to do that process I taught you guys in the last video, where if we're looking at females who like pop, whoa, come on, highlighter, bro. That's 22 right here. But what you need to do is take the total all the way to the right, which is 42, and the total directly beneath, which is 40. So you do 42 times 40 and then divide by the total number of people in the survey. 42 times 40 over 80. So 42 times 40 over 80. Let me crunch that out real quick. Make sure it is what they say. Yeah, it's 21. So there, we proved it. Write down the degrees of freedom. Remember, degrees of freedom are rows minus 1 times columns minus 1 of the original contingency table. I think a nice way, please don't delete the table, to see this, rather than plug it into the formula, is if you're subtracting 1 off the rows and 1 off the columns, you can just shave off a row and shave off a column and count how many are left. 3 cells are left, so you get 3. Or you could do 2 minus 1 times 4 minus 1, and you will get 3 that way as well. So there's 3 degrees of freedom. Now, write down the chi-squared value for this problem. This is where you would punch the original, this table, just this part, not the totals, into a matrix in your calculator, and then you would run the chi-squared test. It's very quick. Much better than doing it by hand. In this case, chi-squared is 1.622. Actually, 2 decimal places, Jolly. That's what you tell us. And the p-value is 0.65. Now, state whether or not the null is accepted or not. Yes, there's 3 degrees of freedom, and I could go look those up in the critical table and then decide whether or not, based on the chi-squared, I'm going to reject or accept. But I think since we're introducing the p-value, let's just use the p-value. So remember, if the p is low, reject the ho. 0.65, we're testing, I think they said to test at a 5% confidence. Are we doing 1? Hold on. I may have written down the problem wrong. Oh, they did say a 1% significance level. My bad. At 1% significance. So, we have to decide the relationship between 0.65 and 0.01. So you say, okay, is 0.65 bigger or smaller than 0.01? It is in fact bigger, so we put an alligator this way. So if the p is low, reject the ho. So if the p is not low, so we're not rejecting the ho, which means we're accepting the ho. What this means in terms of our original hypothesis, gender and music genre favorite choice are independent of each other. Yeah. Last example, American Bulldogs are classified by height, H, as pocket, standard, or XL. Man, I would love an XL Bulldog. Pockets have a height less than 42 centimeters. Standards have a height between 42 and 50, and then XLs are bigger than 50, but less than 58. At a dog show, Marius measures the heights. That's supposed to say heights. Or no, never mind, I'm an idiot. Weighs 50 dogs and is interested to find out whether the class of dog is independent of weight and decides to perform a chi-squared test at the 5% significance level. Here are his results. Now, you guys, this is a ton of data. This is 50 pieces of data. Oh, this is a good time to note. If you're doing an IA, you need a minimum of 50 points of data. So if you were going to write an IA about whether or not Bulldog height and their weight and their height classifications are independent of each other or not, this would be a good set of data because you weighed 50 dogs and got 50 heights, 50 pieces of data. Now, you guys, to be able to find the chi-squared, yes, you could input all 50 pieces of data into your calculator, but it's very daunting. So there's this trick to make this a much smaller table. First, we're going to find the mean weights of the dogs. So the weights are just these numbers. So you would take all these, add them all up, and divide by 50. When you do that, you get 44.96. Is this grams? What is this? Centimeters? Do they not show the units for the weights? What are these, pounds? Oh well. So yeah, the mean weight is 44.96. What you can do is make a new contingency table where the weight is split up between under the mean and above the mean. And then in this description up here, they told us the ranges for the heights for Pocket, Standard, and XL. So you can go through and figure out where all these data points fit. So if you count up all the dogs that have less, what are pockets? Less than 42 centimeters, but also have a weight that's under 44.96. When you do that, there are 13 dogs that fall into that. There are 8 dogs that have standard height but are under the mean weight. And then there's 3 dogs that are XL but are under the mean weight. And then dogs that are above the mean, equal or above the mean weight, there's 3 that are pocket, there's 9 that are standard, and there's 14 that are XL. Now, this is a much better data table to work with because it's only a 2 by 3 as opposed to a 50 by 2. State the null and the alternative. So the weight and height would be independent, would be the the null hypothesis, H sub 0, ho. And then the alternative is weight and height are dependent. Find the degrees of freedom. Once again, I like using that trick where you just shave off a row and a column. So if you take a row off and a column off, that means that there are 2 degrees of freedom in this table. So I'm going to say degrees of freedom is equal to 2. You could use this formula. Degrees of freedom is row minus 1 times column minus 1. But there's 2 rows and 3 columns, so you'll get 2 that way as well. Show that the expected XL dogs under the weight mean is 8.16. Well, I'm going to need some totals for that. If we're looking at XL dogs that are under the mean, the total all the way to the right would be 24. Yeah. And then the total all the way underneath would be 17. And let's not forget there are a total of 50 dogs in here. So once again, you take the number directly below, or the total directly below and the total to the right, multiply them, and then divide by 50. So 17 times 24 over 50 better be 8.16. It is. On the money, too, 8.16. Find the chi-squared and the p-value. Once again, punch it into your matrix in your calculator and then go to stat, tests, do the chi-squared test. Here the chi-squared was 13.4 and the p-value was 0.00125. That seems like a small p-value. What are we testing this at? 5% confidence or significance. So we say 0.00 125, it has what relationship to 0.05? Is it smaller or bigger? Well, 0.00125 is definitely smaller than 0.05, so that means the p-value is smaller than the significance. Remember, if the p is low, reject the HO. So we reject HO, we accept H1, which means Bulldog height and weight are dependent on each other, with each other. All right, you guys, now that you can do that chi-squared on the calculator, like